Hello, so good morning, friends. Today I'm talking about lac operon, positive and negative regulation. So, yesterday I talked about the negative regulation of lac operon, but today I will tell you about the difference between positive and negative regulation of lac operon. So, basically, what is the difference here that I will tell you? So in the positive regulation, the example of regulatory protein involved is activator. Okay, but in the negative regulation case, the example of regulatory protein is repressor. That is the difference between these two, positive and negative regulation. So in the positive control, basically what happens, if the regulatory protein is present, that means if the activator is present, the transcription will go on. Operon is on. But in the negative regulation, if the repressor is there, that operon is off. That is the one difference. Okay. So here, you can see here. So basically, if there is no activator in the second part, can you see this here in the second part? If there is no activator, then no transcription is here, no transcription. And if there is no repressor here, then transcription is there. So that is the two basic difference between positive regulation of lac operon and negative regulation of lac operon. So basically what happens, like as we already know that lac operon in E. coli is regulated by both positive and negative control mechanisms. Okay. Basically, in the case of positive regulation, it refers to the mechanism that enhances the transcription of the transcription of the lac operon genes when lactose is present and glucose is absent. Okay, that I will show you in my detailed slide in the next class. So that is achieved through the CAP and cyclic AMP combination. CAP is catabolite activator protein, and cyclic AMP, when it will bind, then it will start its working. But yesterday we talked about this negative regulation, right? When the repressor is there, then no transcription, and when the lactose is present, then it will bind to the repressor, then it will it cannot able to bind to the operator, then it will start the transcription. So these are the two things what you have to remember, the difference between the positive regulation and the negative regulation of the lac operon. So basically, what is lac operon? Basically, it contains genes that are involved in metabolism. These are the genes which are expressed only when lactose is present and the glucose is absent. The operon is turned on and off in response to the glucose and lactose levels. It depends on both the levels, whether the glucose is more, lactose is more, like this. It will go on and off depending upon the level of glucose and lactose. Okay. So that is catabolite activator protein and lac repressor. So the lac repressor, basically, where is the lac repressor? Here is the lac repressor, block the transcription of the operon, right? And in the presence of lactose, basically it is allowing the transcription, right? That we learned yesterday. And today, that is the positive regulation. When the activator is there, then it will enhance the transcription. That will make the operon on. So I will tell you in detail about this positive regulation, how this works basically. So thank you.